This PPT presentation is about corrosion. Now I would like to give some information about corrosion. Actually, you know that usually metals and alloys are used for construction purposes. If these metals and alloys are not properly maintained, they will undergo deterioration. This deterioration may be either by some of the chemical substances or by moisture or some of the gases. So in short, we can define that corrosion as gradual destruction of any metal on the by the action of any chemical or electrochemical environment. So this is called corrosion. So this corrosion is of two different types. One is dry corrosion and another one is wet corrosion. So dry corrosion can be otherwise called as chemical corrosion, and wet corrosion is otherwise called as electrochemical corrosion. So in this presentation we will discuss about both chemical corrosion and electrochemical corrosion. So first, coming to chemical corrosion, otherwise called as dry corrosion. In this dry corrosion we have three different types of dry corrosion. One is oxidation corrosion, another one is corrosion by hydrogen, and the third one is liquid metal corrosion. First, let us discuss about oxidation corrosion. So oxidation corrosion is brought about by the direct attack of oxygen on the metal surface in the absence of moisture. So in this case, in direct attack of oxygen on the metal surface, it will lead to corrosion. Here we can say that alkali metals like lithium, sodium, potassium, and some of the alkaline earth metals like magnesium, calcium and tin, etc. Will oxidize very rapidly even at very lower temperature. Almost all metals will oxidize at higher temperature. Now let us discuss about mechanism of dry corrosion. So in this diagram I have given about the mechanism of dry corrosion by oxygen. So here we can see that mechanism. The first step is oxidation first occurs at the surface of the metal, and this oxidation occurs at the oxide environment interface, metal and oxide interface. So here metal lose electron and the lost electron is gained by oxygen, and this electron is gained by oxygen at the oxide film and environment interface, and the oxide is converted into ionic form. So finally the metal and the ionic form of metal ions and the ionic form of oxygen combine together and it will produce metal oxide, and this is nothing but the corrosion. So the metal oxide that is formed on the surface of the metal is of four different types. One is stable oxide layer, another one is unstable oxide layer, and third one is volatile oxide layer, and another one is pilling bedworth ratio. So first we will discuss about stable oxide layer. So in this the oxide layer that is formed on the surface of the metal, the stable oxide layer that is formed on the surface of the metal is fine grained structure, and it gets absorbed tightly on the surface of the metal, and also it is impervious in nature. Moreover, further oxygen is not allowed to attack on the metal again. So it behaves as like a protective coating. So this stable oxide layer usually occurs in the metals like aluminum, tin, lead, copper, etc. Then coming to unstable oxide layer, this unstable oxide layer is produced on the surface of the metal. Here we can say some of the examples like platinum, silver and gold. Here we can see that the metal oxide decomposes back again into metal oxygen. So it is called unstable oxide layer. And the third one is volatile oxide layer. In this volatile oxide layer, the oxide layer will volatilize soon. It means that, for example, if you take molybdenum, this molybdenum will produce MoO3, and the oxide film that is formed on the surface of the molybdenum will evaporate soon. So it gives way for further oxygen to attack on the surface of the metal. And the fourth one is protective or non-protective oxide film. Otherwise we call it as pilling bedworth rule. So this pilling bedworth ratio is nothing but the ratio of the volume of the oxide formed to the volume of the metal consumed. So here we can say two categories. The first one is if the volume of oxide layer formed is less than the volume of the metal consumed, then the oxide layer that is formed is very much porous and it is non-protective. So this type of oxide layer will be usually formed on the surface of the sodium, magnesium, calcium. And if the volume of the oxide layer that is formed on if the volume of the oxide layer that is formed is more than the volume of the metal, it means that the oxide layer is non-porous and it is protective. So here the metals like lead, tin, these are heavy metals. These type of heavy metals will produce protective and non-porous oxide layer. Next, the second type of dry corrosion is corrosion by hydrogen. See here we have two different types of corrosion by hydrogen. One is hydrogen embrittlement and another one is decarburization. So in hydrogen embrittlement, here we can say that when hydrogen sulfide comes into contact with metal, even at ordinary temperature, it will produce evolution of oxygen. For example, we can see that reaction, the hydrogen sulfide, when it comes into contact with the iron metal, it produces atomic hydrogen, and this atomic hydrogen will diffuse into the metal and it will be collected in the voids of the metal and it will form molecular hydrogen. This molecular hydrogen that is formed inside the voids will create some pressure and it will produce some cracks and blisters on the surface of the metal due to high pressure. So this is called hydrogen embrittlement. And the second one is decarburization. Decarburization, here in this case, it occurs at higher temperature. Here, the atomic hydrogen that is formed is by thermal dissociation of molecular hydrogen. See here in this slide, we can see that the atomic hydrogen that is formed due to thermal dissociation comes into contact with the carbon that is present in the steel and it produces methane gas. So this methane gas once produced will decrease the percentage of carbon that is present in the steel. So this is called decarburization. And third type of dry corrosion is liquid metal corrosion. In this liquid metal corrosion, it happens in two different cases. Either dissolution of the solid metal may be happen by a liquid metal, otherwise the liquid metal may penetrate into the solid metal. Here we can say that example, usually sodium metal is used as a coolant and this sodium metal will lead to corrosion of cadmium in nuclear reactors. Now next coming to this wet corrosion. This wet corrosion is another way called as electrochemical corrosion. So this electrochemical corrosion happens in two different cases. The first case is when two different metals comes in contact with each other, then definitely their electrochemical reaction will occur, because when two different metals comes in contact, one of the metal will function as anode and another metal will function as cathode because of the variation in electrode potential. So in such cases, electrochemical reaction will happen there. And the second one is when a metal is exposed to varying concentration of oxygen. It means that if you dip a metal into a liquid, the upper part of the metal will be at the higher oxygen concentration and the lower part of the metal will be at the lower concentration of oxygen. So in this case, the part that is immersed inside the liquid will function as anode and the part that is outside the liquid will function as cathode. Here also an anode and cathode is set up and we have electrochemical reaction there. So now let us discuss about the mechanism of electrochemical reaction. So in this electrochemical reaction, the anodic reaction is the same. Here the dissolution of the metal take place and because of that the metal will be converted into metal ion. But coming to the cathodic reaction, here we have two different type of cathodic reaction. One is hydrogen evolution type cathodic reaction and another one is oxygen adsorption. This hydrogen evolution usually occurs in acidic medium and oxygen occurs usually in presence of oxygen. So here in this diagram we can see the mechanism of wet corrosion. mainly for hydrogen evolution type corrosion. See, in this diagram, we can say that this corrosion occurs in acidic medium. So now we can consider this metal as iron, and it is kept in acidic medium, and because of that, the metal ion undergoes oxidation, and because of that, electrons is lost in the oxidation reaction, and the lost electron will pass to the acidic medium, and it will be absorbed by the H plus ion, and it will be reduced to H2 gas. So here the cathode reaction is the production of H2 gas because of the reduction reaction. And the second type of wet corrosion, the second type of cathode reaction in the wet corrosion is absorption of oxygen or formation of hydroxide ion type corrosion. Here you can see that diagram. In this diagram, we have the metal ion. Usually the metal ion has some oxide layer on the surface. As time passes, the oxide layer will grow, and because of that, at particular time, there will be some break in the surface of the metal. The point where we have a break on the surface of the metal will act as an anode, and the remaining part will act as the cathode. See, in this case, we have the break at a particular point in the diagram, and the place here we have ion is converted into Fe2 plus ion because of oxidation reaction, and the electrons are lost, and these electrons are absorbed by OH these are absorbed by oxygen in neutral medium, and it forms hydroxide ion. So finally, this metal ion Fe2 plus and the hydroxide ion combine together, and it produces ferrous hydroxide. And if there is excess of oxygen in that place, it will be converted into Fe2O3, ferric oxide. So finally, I thank everyone for watching this video. I thank you everyone.